So what is magnetic variation and how does it affect us? As we know, all latitude lines running vertically up our charts converge at the North Pole. The single point where they meet is known as true north. Unfortunately for us, our compasses don't point at true north, as magnetic north is not located at the North Pole. This means we have to make an adjustment to our bearings to use a compass with our charts or vice versa. If we simply followed our compass and travelled due north, we'd end up at the magnetic North Pole. So our compass is directing us to magnetic north, while our charts are pointing at true north, and the difference between them is called variation. As probably our primary navigation tool, we need to know what the difference is and what to do about it. Otherwise, anything we do on our charts won't line up with our compass, or vice versa. It's a localized problem too. The difference between true and magnetic north varies depending on where we are in relation to the two. Magnetic north could be west or east of true north, and the angle between the two could be large or small in relation to our position on the globe. Oh, did I mention? Whilst exaggerated for effect, magnetic north is also moving, so the direction our compass points will change over time. Of course, this means variation, the difference between magnetic north and true north, will change over time too. To get a sense of the change, let's take a look at the movement of magnetic north in relation to the North Pole plotted over time. Long being a need for navigators, the understanding and monitoring of magnetic north stretches back a long time. Official observations have been recorded since the early 1800s, and in more recent years modelled forecasts have been made to predict future movement. Current observations have roughly kept in line with the modelling of projected changes, although very recent observations have shown that the rate of movement appears to be increasing. So what do we need to know, and how do we find out the impact of variation on our navigational requirements? Well, firstly, as the impact of variation changes depending on where we are in the world, the information we need to answer this is given to us on our charts. Then, to understand its impact and how to deal with it, we need to know two things. We need a fixed reference point, in other words, what variation was at a given time. Once we have this, we need the modelled speed and direction of change since the fixed reference point. This will enable us to calculate what it will be today. If we look at any chart, it will have a compass rose. This contains the locally relevant information about magnetic versus true north. After all, variation changes depend on where we are. It's the compass rose that answers our two important questions, allowing us to calculate the adjustment we'll need to make to a magnetic bearing to align it with our charts. The arrow in the middle of the compass rose gives us the information we need to answer those questions. It starts by giving us the amount of variation immediately followed by the year this was true. The number in brackets is the annual change to variation in this location. Armed with this, we can work out what variation is today. Let's calculate variation for this location on the chart. We'll construct a statement and work it from there. Variation was 4 degrees 25 minutes west in 2007 and is changing 9 minutes east annually. So we know what it was 13 years ago. This calculation was done in 2020. And we're also told it's been changing in an easterly direction by 9 minutes every year since then, therefore reducing the westerly variation that's now 13 years old. So the error has moved easterly 117 minutes in the 13 years since 2007. 9 minutes multiplied by 13 years. We have to convert the total minutes into degrees and minutes, and given there are 60 minutes in every degree, it looks like a little under 2 degrees. The 13-year-old variation has been reduced by 1 degree 57 minutes. The variation change is easterly, the opposite direction to the westerly variation in 2007. So we need to take away 1 degree 57 minutes from the original value. 4 degrees 25 minutes west less 1 degree 57 minutes east equals 2 degrees 28 minutes west, the variation at this location in 2020. Rounded to the nearest degree would be 2 degrees west. Now we know our compass is different from our charts, in this case pointing 2 degrees further west than true north, we can alter how we use it. We need to introduce the concept of having 2 bearing types, true and magnetic. This allows us to differentiate between them, and using the known difference we can link our compass bearings to our chart bearings and vice versa. If we wanted to use our compass to head due north on the chart, a bearing of 000 degrees true, we need to account for the variation that we know exists on our compass. Having just calculated variation to be 2 degrees to the west, if we add this westerly error to the true bearing, we make our compass and chart align. So steering 002 degrees on the compass is the equivalent of heading straight up the chart. How about if we're using our compass to take a bearing, perhaps of a charted object? Well, the error will still exist, so we need to account for it. If we took a bearing to a physical object using our compass, let's say this lighthouse on a bearing of 092 degrees magnetic, the westerly variation means my compass is 2 degrees further west than my chart. So I need to take the westerly variation away from my compass bearing to match it to the chart. Taking away 2 degrees from my compass magnetic bearing gives me a true bearing of 090 degrees true. So my relationship to the charted object on the chart is 090 degrees true. Of course, depending on where we are in the world, variation could be easterly too, so we have to think about which way we are making correction. All the principles remain the same, but the adjustments are opposite. Instead of adding variation to a true bearing to make it the same as a compass bearing, we need to subtract it, as the error is in the opposite direction. To help us remember which way to apply corrections, we can use a simple mnemonic. Cadet, or from compass add east for true. So for compass, magnetic bearings, we need to add an easterly variation to convert it to a true chart bearing. Therefore, going the other way round, from true to compass, magnetic, we would need to subtract an easterly variation. So if this is a way to remember what to do with an easterly variation, then we simply need to reverse everything for a westerly variation.